I'll be talking about forces on an object when it is falling and talk about air resistance, and I'll be using the example of a parachutist. When a dude jumps off a plane, he's accelerating. He's just jumped off the aircraft, so he'll be starting from a speed of 0 and then accelerate and get faster and faster. But as the parachutist gets faster and faster, the air resistance will increase, and soon, when he gets fast enough, the air resistance will increase so much as to equal the weight of the parachutist, and this means that these forces are equal, so her speed stops increasing and stays constant. So she's basically reached her terminal velocity where she or he can't get any faster. Once reaching terminal velocity, the parachutist will open the parachute, and this will dramatically increase the air resistance, so the parachutist slows down like a lot and decelerates. And for a few seconds, the air resistance is greater than her weight, as she has suddenly opened up her parachute. But as she decelerates, the air resistance also decreases, so soon the force of the air resistance and her speed will be equal, and she'll reach her second terminal velocity where she can't go any slower. So her speed is constant again, and she has a much slower, but it's still called a terminal velocity, as it's a constant speed, and the forces are in balance. Now the parachutist has landed, and so on the ground her speed drops immediately to 0, as she's not moving anymore, and the parachutist will experience a big force upwards from the ground, as the force from under her or him will be much greater than the force pulling her down, and so she will decelerate until her speed is 0, and that's why parachutists crouch down when landing, so as to absorb the force and not cause injury to the legs. The graph of this motion will look something like this, and this is where the person is dropped out of the plane, and he'll accelerate really quickly and reach this part here. The person's accelerating, he hasn't opened the parachute yet, and over here the person's reached the terminal velocity, so he can't move any faster anymore, and then over here he's dropping, and the speed is decelerating, and this is because he's opened the parachute. Now is decelerating almost immediately, as the parachute provides a lot of surface area for the air resistance to work on. It's dropped, and then over here the force from under the parachutist is now balanced and equal to the force pulling her down, and so over here she's reached the new slower terminal velocity where she can't go any slower, and then over here she's finally landed and stopped, so it's a speed of 0.